Om Shri Mahaperivar Sharanam. In this episode, let us see how to solve some HOTS questions, that is higher order thinking skills questions from class 10. The first question: find the greatest number of 6 digits exactly divisible by 24, 15 and 36. Let's understand the question. Find the greatest number of 6 digits which is exactly divisible by 24, 15 and 36. Now, the greatest 6-digit number is 9,99,999, right? But we have to find the greatest 6-digit number which is divisible by 24 and 15 and 36. That number must be a multiple of 24 and 15 and 36. So what do we do first? So we have to first find LCM. Let's find the LCM. So the LCM of 24, 15 and 36 comes to 360. So this is the lowest common multiple of 24, 15 and 36. So all multiples of 360 will be divisible by 24, 15 and 36. But we have to get the greatest 6-digit number that is divisible by the given 3 numbers. So what do we do? Let's see. If we divide 9,99,999 by 360, we get the quotient as 2,777 and the remainder as 279. So that means that 279 is the remainder, that is something extra. So if you deduct 279 from 9,99,999, we get the required number. That is exactly divisible by 24, 15 and 36. So if you subtract 279 from 9,99,999, you get 9,99,720. This 9,99,720 is the greatest number of 6 digits which is exactly divisible by 24, 15 and 36. Now try to work out a similar question. Find the greatest 5-digit number divisible by 12, 16, 18 and 21. Now, the greatest 5-digit number is 99,999. But we have to find out the greatest 5-digit number divisible by 12, 16, 18 and 21. So we first find out the LCM of 12, 16, 18 and 21, which is 1008. What's the next step? We divide 99,999 by 1008. We get the quotient as 99 and the remainder as 207. So if we subtract 207 from 99,999, we get the answer as 99,792. This is the answer. Or we can just multiply 99 by 1008, which is again 99,792. So you get it, either we subtract the remainder from the dividend or just multiply the quotient with the divisor to get the required answer. So 99,792 is the greatest 5-digit number divisible by 12, 16, 18 and 21. Now another type of question. Find the smallest number which when divided by 28 and 32 leaves remainders 8 and 12 respectively. Now when you see the word smallest number, it gives a hint that we have to find the LCM. Let's first find the LCM of 28 and 32. When we work it out, we get the LCM as 224. So 224 is the smallest number which is exactly divisible by both 28 and 32. But the question is, we have to find the smallest number which when divided by 28 and 32 leaves remainders 8 and 12 respectively. It doesn't leave remainder 0. So let's see. Now 224 is exactly divisible by 28. It is 28 into 8. Let's put it this way. 28 into 7 plus 28, right? That is equal to 28 into 7 plus, it says, the question says it leaves remainder 8, right? So let's put 8 over here, okay. So this 28 is split as 8 plus 20, you got it? Now we transfer 20 to this side. So 224 minus 20 is equal to this number, 28 into 7 plus 8. 224 minus 20 is 204, okay. So 204 is the number which when divided by 28 leaves remainder as 8. Let's go to the other number. Let's see what we get when we work out in the similar way with 32. So 224 is exactly divisible by 32, but we have to find the number which when divided by 32 leaves remainder 12. So in this case we can split it as this, 32 into 7 as 32 into 6 plus 32, and then we split 32 as 12 plus 20 because it leaves a remainder of 12. Again 32 into 6 plus 12, and you bring 20 to this side. So this is 224 minus 20 equals 32 into 6 plus 12. So this number 224 minus 20 also gives us 204. So both cases give us the same number as 204. So 204 is the smallest number which when divided by 28 and 32 leaves remainders 8 and 12 respectively. Okay. Let's go to the next question. Now try to do this one. Find the smallest number which when increased by 20 is exactly divisible by 90 and 144. This is pretty easy. First we find the LCM of 90 and 144, which comes to 720. Now the question says find the smallest number which when increased by 20 is exactly divisible by 90 and 144. So the required number is LCM minus 20, which is 720 minus 20, that gives us 700. So 700 is the smallest number which when increased by 20 is exactly divisible by 90 and 144. Now the next question. Using Euclid's division algorithm, find the largest number that divides 1251, 9377 and 15628, leaving remainders 1, 2 and 3 respectively. Pause the video and try to do on your own. First, when we read the question, we have the three remainders as 1, 2 and 3, which means without the remainders, the three numbers will be 1250, 9375 and 15625. Now, we need to find the HCF of these three numbers using Euclid's algorithm. First, we can use Euclid's algorithm to find the HCF of 1250 and 9375, and then find the HCF of that result and 15625. So the first step, HCF of 1250 and 9375 is 625. The second step is the HCF of 625 and 15625 is 625. So the result is the HCF of 1250, 9375 and 15625 is 625. This is the largest number that divides 1251, 9377, 15628, leaving remainders 1, 2 and 3 respectively. If you have any doubts or clarifications, please write in the comment box. See you in the next class. Om Shri Mahaperiva Sharanam.